Hello, my lovely viewers. Welcome again to Mathematics and I remain your presenter, Jeff Nino. And today on the board we have simplification of logarithms. We have 4 questions here, and we are told to simplify them. So we are going to be solving these problems using the laws that we treated from the first class, the laws of logarithm. So without wasting time, let us begin the class. Now, question number 1. Question number 1 says simplify log root 27 over log root 81. Now, when you are given a question like this to solve, either in an examination or in a textbook or wherever, how do you solve problems like this? Now, the first thing you have to do when a log question is given to you is that you look at the base. Are the base different or are they the same? Now, you would notice that there is no base at all in this mass. And I told you last time that when there is no base, what base is there? Base 10. Now, it means the log at the numerator is carrying base 10, and the log at the denominator is also carrying base 10. Now, we are done with that part. The bases are the same. Now, what do we have to do next now? We have to remove these roots, and we have to remove these roots. Now, let's see. In mathematics, root A is the same thing as A raised to the power half. Cube root of A is the same thing as A raised to the power of 1 over 3. The fourth root of A is the same thing as A raised to the power of 1 over 4. So what does that mean? It means that the nth root of A is what? A raised to the power of 1 over n. So it means now that, automatically becomes log 27 raised to the power 1 over 2. Where did I get this 1 over 2 from? From the roots. All over, here becomes log 81 raised to the power of also 1 over 2. Okay, now we're done with that step. The number here is 27, the number here is 81. Now there's a number that we can break 27 and 81 to, and that number is 3. Now, how many times are we multiplying 3 to get 27? Now, 27 is 3 times 3 times 3. And in index form, it is what? 3 raised to the power 3. Now, 81 is 3 times 3 times 3 times 3, which in index form is 3 raised to the power 4. So what does that mean? It simply means that anywhere I see 27, I give 3 raised to the power 3, and anywhere I see 81, I give 3 raised to the power 4. So the mass becomes log, instead of 27, I write 3 raised to the power 3 times 1 over 2, which was the former power. All over, here also becomes log 3 raised to the power 4 times 1 over 2, which is the former power. Now, here becomes log 3. 3 times 1 over 2 is 3 over 2. All over. 4 times 1 over 2 is 4 over 2. And 4 over 2 is 2. Now, you will notice that the number here is now 3, the base is 10. The number here is also 3, and the base is 10. Now, what do? 3 over 2, according to the law that says, when the number carries, for instance, if you have log x raised to the power n, this n goes to the back. We discussed this in our first class, and it becomes n log x. So automatically, when 3 over 2 goes to the back of log 3, it becomes 3 over 2 log 3 all over. Now, when 2 also goes to the back, it becomes 2 log 3. Now, see, you can only cancel out your log when the number and the base are the same. You will notice that my number here is 3, my number here is 3, my base here is 10, my base here is 10. So what happened? They all cancel out. So what do I have left now? At the numerator, I have 3 over 2. Now, the word all over also means what? Divided. Just like if I have A over B, is the same thing as A divided by B. So divided by, what do I have at the numerator now? 2. Now, in mathematics, division changes to times. Now, when division changes to times, 2 reciprocates. The fraction after the division sign reciprocates. So here becomes 3 over 2. Division becomes times. When 2 reciprocates, it becomes 1 over 2. Now class, 3 times 1 will give us 3, and 2 times 2 will give us 4. So it means when we simplify log root 27 over log root 81, our answer will be 3 over 4. Now class, taking us to question number 2. Question number 2 says, simplify log 125 over 8 to the base of 10 minus 2 log 5 over 4 also to the base of 10. Now let's start. I told you whenever a log question is given to you, the first thing you observe is the base. Are the base the same? Now the bases are the same, base 10, base 10. So what is the next thing you do? These two, you will see that there's no number at the back of log, but there's a number here too. So what happens? The 2 goes back. Now when the 2 comes here, it becomes a power again. So here becomes log 125 over 8 to the base of 10 minus, now the 2 is no longer here. What's not here now? Log. So what will now be here? 5 over 4 raised to the power of 2 that left to the base of 10. So what do we now have? Log 125 over 8 to the base of 10 minus log. Now, this power 2 is affecting everything in the bracket. So this is simply means 5 raised to power 2 over 4 raised to power 2. And we all know 5 raised to power 2 means 5 times 5. And what is 5 times 5? 25. And what is 4 raised to power 2? 4 times 4, which is what? 16 to the base of 10. Now, we simply apply law 2, which says subtraction law. That when the bases are the same and you are subtracting, what do you do to the two numbers? You divide. So automatically, I come here, I'll pick one of the log and I will open a bracket. The first number here is 125 over 8. Minus becomes division. What do I have here? 25 over 16, all to the base of 10. Now, like we said in example number 1, division changes to times, and then the fraction that follows reciprocates. So here becomes log into the bracket of 125 over 8. Division becomes times. Now, when this reciprocates, it becomes what? 16 over 25. Are you with me? Now, without wasting time, to the base of 10. Now, we can simply do some cancellation here to make the math easier. Now, we now have this log. I believe 8 cancel itself is 1, and 8 cancel 16 is 2. And also, 25 cancel itself is 1, 25 cancel 25 is 5. So what do we now have left in this math? 5 times 2. So here becomes 5 times 2 to the base of 10. Now we all know that 5 times 2 is 10. So what do we now have, class? Log 10 base 10. Remember in one of the laws that we treated, we said when the number and the base are the same, what is the answer? 1. So it means when we simplify log 125 over 8 to the base of 10 minus 2 log 5 over 4 to the base of 10, the answer we are going to get is 1. Okay, taking on to the next question, which is question number 3. Question number 3. Now, question number 3 says, simplify 2 plus log 20 base 10 minus log 2 base 10. Okay, now the first thing I said, observe the base. You will take a look at this guy. There's no base here, in fact. But there's a base 10 here, there's a base 10 here. Now, my main aim now is to see how I can make 2 carry a log of base 10. Now, this is what I will just come in. I will write 2 log 10 base 10 plus log 20 base 10 minus log 2 base 10. Now, the question is, why did I use log 10 base 10? Good. First, I use base 10 here because other bases are in base 10. Secondly, I use number 10 here because it is only when number 10 is here that log 10 base 10 will give us 1. And when this case is 1, 2 times 1 will give us 2, which was the original question. So automatically we said there is no number at the back, there is no number at the back. So 2 has to go up and becomes a power. So here becomes log 10 raised to the power 2 to the base of 10 plus log 20 base 10 minus log 2 base 10. Now we all know 10 raised to the power 2 means 10 times 10, that is 100. So here becomes log 100 to the base of 10, plus log 20 to the base of 10 minus log 2 to the base of 10. Now class, you will see and you will smile. You will notice now that the base here is 10, the base here is 10, the base here is 10. Now all are carrying base 10. So what do? Pick one of the log. Open a big bracket. Now the first number here is 100. Plus changes to times. My next number here is 20. Minus changes to division. Divided by what number? By 2 to the base of 10. So class, when you do this, it becomes log. I believe 2 can cancel 20 to give me what? 10. So what do I have on top now? 100 times 10 to the base of 10. You must not forget your base. Now what do? 100 times 10 gives us 1000. So here becomes log 1000 to the base of 10. Now I can't leave my answer like this, never. Because why? I can break 1000 to base 10. And how do I do that? How many times will you multiply 10 to get 1000? I think, let's go. 10 times 10 is 100. 100 times 10 is 1000. So it means when I multiply 10 3 times, I will get 1000. And how does that mean in index form? 10 raised to the power 3. So here becomes log 10 raised to the power 3 to the base of 10. Automatically, where will this 3 go to? To the back. So here becomes 3 log 10 base 10. And remember the law that says when the number and the base are the same, the answer is 1. So what do we now have? 3 into brackets 1. And what is 3 times 1 plus 3? Question number 3. And the last question that we have for today, which is question number 4, says, question number 4 says, simplify log 3 minus log 2 all over log 9 minus log 4. Okay, now take a look at this question. Simple. The base here is 10, the base here is 10, and we have minus. And we say when the base are the same and we have minus, what do we do to the numbers? We divide. So I come here. I'll pick one of the log here, and I'll open a bracket. The first number is 3, minus becomes all over, that number is 2. Good. All over. Also, my base here is 10, my base here is 10, and I was subtracting. So it also becomes division. I'll pick one of the log. My first number is 9, minus becomes all over, my other number is 4 to the base 10. Now, look up. Class. It will be crazy when you tell me this log cancel out this log. Why? Because although the base are the same, yes, the base are the same, base 10, but the numbers are not the same. I told you, for log to cancel out log, not only the base should be the same, the number and the base must be the same. So class, what does that mean? It means that how can I make 9 over 2 becomes 3 over 2? It is very simple. You will notice that the number at the numerator here is 3. The number here is 9. I will break 9 to 3. The number at the denominator is 2. The number here is 4. I'll break 4 to 2. And this becomes what? Log 3 over 2 over log. Watch now. I believe if I break 9 to 3, it is what? 3 raised to the power 2. And if I break 4 to 2, it is what? 2 raised to the power 2. Now, you will notice that both numbers are carrying same power, which is power 2. So how would you represent this? It becomes log 3 over 2 over log 3 over 2, all raised to the power of 2. Now you see, the same powers that are here, I took it out. and put it as a power outside. Remember I told you when the power is outside, it affects everything inside the fraction. So class, what happens here? Watching. Look at what's going to happen here now. Now see, because this 3 over 2 is carrying 1 and it's carrying 2 as the power. Where will this 2 go to now? 2 will go to the back. So if 2 goes to the back, what will have in this math? It becomes log 3 over 2 over 2. These 2 going to the back now. Log 3 over 2. Aha, that's it. Now you now notice that my number here is 3 over 2, my number here is 3 over 2. My base is 10, my base is 10. So what happens, class? They cancel out. Now when they cancel out, what will remain on top? 1. And what do we have down? 2. And our answer becomes what? 1 over 2. So class, I believe you have enjoyed yourself with these 4 questions that we solved under simplification of logarithm. In our next class, we are going to be looking at logarithm that involves different bases, because if you take a look at today's class, all the bases were the same, base 10. So in our next video, we shall be looking at when the bases are different, what should you do? What should be your next step? If you know you enjoyed this class, please subscribe to the YouTube channel, like, and share your comments. Tell me how you feel. Tell me if you really understood what I taught or how you want it to be. Till we meet again in our next class. My name remains Jeff Nine. Thank you very much.